Alright, we're going to factor this polynomial by grouping. So normally when we do factoring by grouping, what we try to do is we try to group the first two terms together and the second two terms together. We usually know that we're going to do factoring by grouping because there are usually 4 terms in the polynomial. Now, when there's a minus sign in the middle of the 4 terms, we need to rewrite that minus as a plus. And we're going to write it so it says plus a negative. Because every subtraction problem can be rewritten as an addition problem. Right? We add the opposite. So the reason we need to do this is because if we do not do this and we choose to group, it looks like we factored out a negative when we didn't. So this is very important. Make sure you rewrite that minus sign as plus a negative. After you do that and you have that plus sign in the middle, now we can start grouping. Alright, I'm going to group the first 2 terms together, and the way I'm going to group the first 2 terms together is I'm going to use a set of parentheses to show this grouping. So we're going to draw some parentheses around the 6xm plus the 3xn, and now I'm going to draw some parentheses around the negative 4ym and this minus 2yn. So let's draw those parentheses. Now what we're going to do is we're going to try to factor out here the greatest common factor of the first 2 terms. So I'm just going to quickly write out the factors of these so we can compare common factors. I can see that these 2 terms both share a common factor of 3 and of x. So that's going to be my GCF for the first 2 terms. We're going to factor out a 3x. So 3x times the quantity, and what's going to be left over is going to be a 2m. And I'll put that plus sign there. And if we divide 3xn by 3x, we're just going to be left with a factor of n. Let's write that n. Now I'm going to look for the GCF of the second 2 terms. Now since you see that these are both negative here, I want them to be positive because ultimately I want the 2 binomials I'm going to be left with here to be looking the same with the same sign. So I'm going to factor out that negative so that I can turn both of those terms positive. And that will leave me with a binomial, hopefully, that will look a lot like my 2m plus n. So I can end up factoring that out. So that's very important. The signs, we have to try to make the signs of this, whatever's inside this set of parentheses, look the same as our first set of parentheses. Now let's look for the GCF. Looks like the factors of our first term there. We got 2 times 2, we got a y, and we have an m. And this one we have a 2, a y, and an n. So if I compare the factors, it looks like the greatest common factor of these 2 is going to be 2y. Let's factor that out. We already factored out a negative, so it's like we're actually factoring out like a negative 2y. And we're going to be left with positive 2m, because that's what's left over there. Let's write that down. We're going to have 2m plus, because we factored out a negative, n. And now if you notice, we have the exact same binomial here. We have a 2m plus n, and here we have a 2m plus n. That's a common factor. So we can actually factor out that entire binomial. Okay, so I'm going to write that common factor of 2m plus n. That's going to be my GCF, and I'm going to factor that out. Now what I'm going to draw here is I'm going to draw some square brackets to really emphasize that I'm factoring out this entire binomial. Okay, you don't have to draw square brackets. I'm doing it for emphasis. So this is what's going on here. This is like an in-between step. You might not have to write this step down. Some people might have to write this step down if they still don't understand what's going on here. When we factor out a GCF, it's like we're dividing by that GCF. So I wrote the GCF outside the square brackets, and inside the square brackets I'm trying to show that we're dividing through by that GCF. That factor of 2m plus n is going to cancel out, and what we're going to be left with, we'll be left with the 2m plus n that we factored out. And now I'm going to use just parentheses. We're left with a factor of 3x minus 2, and that's going to be left inside this set of parentheses. And this is it. We're done. These are the factors of our original polynomial. And if we wanted to check this, we could actually check this by multiplying the factors. Any factoring problem, you can always check it by just multiplying out the factors you get at the end. You should always be able to come up with the original polynomial. Okay, I'm going to use this the box method, or you could use the FOIL method to multiply these two binomials together. So I'm going to multiply 2m plus n multiplied with 3x minus 2y. 3x times 2m is going to give me 6xm. 3x times n is 3xn. Negative 2y times 2m is negative 4ym. Negative 2y times n is negative 2yn. Okay, and if we notice here, we see all the original four terms of the original polynomial that we were given. And that's going to tell us that we definitely got the correct answer. We look up at the original polynomial, we can see it's exactly the exact same four terms we had before. So that means our answer, our boxed answer here, is correct. The factors of the original polynomial are in fact 2m plus n times the quantity 3x minus 2y. This represents our final answer. Alright, thanks for watching.